Moving on to question 6a, and this is a projectiles question, so I'm going to give you a little rundown of what's happening. So I've got two particles, P1 and P2. Now P1 is fired at an angle of theta to the horizontal at a velocity v, and it goes like in a parabolic path. Particle 2, however, is fired vertically upwards at the same velocity of v meters per second, and it goes like that. So now this question focuses on the actual distance between the two particles, and we call that L. So as they move, you can imagine the distance varies because they get closer to one another. So we're going to be considering L for this question. Okay, so how do we begin? Well, if we're talking about distance between 2 points, well, that's a formula. It's the distance between 2 points in a Cartesian plane. So we just need to figure out the coordinates of these points, but we're given the conditions of their motion. Like, for the instance, x for particle 1 is given by vt cos theta. So that's pretty much what their coordinate is. You can write their coordinate in the plane as a function of t. See, it's just like parametrics. Vt cos theta and vt sin theta determine their x and y values. So we're going to be doing that by doing the distance formula. So we'll call it L. And as you know, the standard distance is like x1 minus x2 squared plus y1 minus y2 squared. So we're just going to be substituting these values for these values. So let's get started. So first we'll take the difference between the x values. So we've got vt cos theta for the particle 1, and we take away a because that's the x value of particle 2. And then we add the y value of particle 1, which is vt sin theta minus half gt squared. And we subtract that from vt minus half gt squared from particle 2. Okay, now we're going to simplify this. So for the first bracket, as you can see, we can expand that by our binomial expansion. So vt squared vt squared cos squared theta minus 2a vt cos theta plus a squared. Pardon me. And now we're going to simplify this because you see minus a half gt squared plus half gt squared equals 0. So we've got vt sin theta minus vt squared left. Alright, so we're going to continue. So now I'll square both sides because we've got a square root here and L. So if I square both sides, now I get that L squared is equal to v squared t squared cos squared theta minus 2a vt cos theta plus alpha a squared. And now expanding this, we're going to get v squared t squared sin squared theta minus 2v squared t squared sin theta plus v squared t squared. Okay, so if we notice v squared t squared cos squared theta, they all have the same coefficient of v squared t squared. So we'll factorize that. So we'll take out v squared t squared and in a big bracket write cos squared sin squared and 1. So now we can get rid of those terms as we look at it. So now what's left? We've got minus 2avt cos theta plus a squared, and we've got minus 2v squared t squared sin theta. So now if you look at this, cos squared plus sin squared equals 1. So now 1 plus 1 is 2. You need 4-unit maths for that bit, but it's alright. And vt cos theta and 2v squared t squared sin theta. Now again, we realize v squared t squared is also there, and they also have 2's out the front as well. So we're going to factorize out 2v squared t squared. And now that's 1, and then we've got minus sin theta left. And the remaining part, we've got minus 2a vt cos theta and plus alpha squared. And that's it. We've shown that L squared equals that. There you go.